Oh, that's excellent. Yeah, no, I just popped in a few minutes ago. I heard last discussion here about open source software, and definitely got to say that I could not agree more with what you all were talking about. It's amazing to see like not only what people make and put out there, but what you can make with it so quickly. I'm always amazed when I have an idea for something that seems relatively complex to me in the moment, and I do a little bit of research and find some parts and pieces around, and then manage to put it together much quicker with the help of everyone who's come before and published their work. So really a lot of great stuff going on. Yeah, definitely. I've been I have been held back sometimes by like similar ideas, right? Like have an idea and it's not good enough, or I don't think it will be useful to anybody else. But um, there have been times when I've gone through with it a few times and published it anyway, and then months or even years later, somebody will pop up in the comments or whatever and mention that it helped them get through whatever they were working on, or they built it into something more interesting and better. And so like that's definitely an eye-opening thing to see and experience, and definitely helped push me more towards just wanting to publish everything I can, even if it's doesn't feel ready yet or doesn't feel useful to other people. But you never know when it will pop up. Yep. Yeah, I don't know too much of the specifics, but I know there are a couple of different kinds of protocols or frequencies or something that they can communicate over. But generally, they kind of do the same kind of thing. They give you a kind of like a connection you can share bytes back and forth with. It's kind of like a serial connection or something like that, but through the radio waves. If you're interested in inspiration, if I understand the messaging thing that you were talking about, I have kind of like a primitive, almost emailing type thing. You can send a message to an address, and then there's a inbox, and you can mark the messages as read, or you can reply back to them. Um, that sort of thing. It's like super basic version of it though. So you can kind of send text back and forth between one or more nodes, and you can like target which one you want to send it to. Ah. Hmm. I had pretty good success when I did it with the axe, but I will say also I was in like I did not push the network conditions at all. I always everything I've done has been with like both devices basically right next to each other. Um, I did have I thought I did at least last time I messed with it. It's been a little while. Grab the link if you're interested in seeing. I can't remember exactly which devices I had. I think Featherwing. Oh yeah, they I guess it's kind of a weird interface, but it's like a serial command line tool. You connect to it over serial, like with TO or whatever serial connection you want, and then it's command line stuff. So like, send to address, and then it will prompt you for the message. It kind of has its own little command line interface. So you don't need a keyboard on the microcontroller. You still just type in through a PC or through some other serial connection. I gotcha. Yeah, yeah. Feather, keyboard, keyboard Featherwing or yep. Hey there, Vishuri. Let's see. Sorry, Vishuri for games. Appreciate the follow there on Twitch. Thanks for tuning in. Sorry, I'm also not talking a whole lot. The conversation is going on over in the CircuitPython Discord. Today's our first ever CircuitPython help desk. So for folks who want to get help with contributing or projects or anything like that, they can join us either on text chat in the Discord or over in the voice channel, get help with stuff. So that's kind of where I'm at and what I've got in my earbud here. If you're interested in joining the conversation over there, you certainly can. Or if you're just liking to watch along here, that's totally cool as well. Thanks for hanging out either way. It does. Okay. Or is very well split up. Looking over this typing, probably update like a number. It is none, I suppose. Floats. X for an int, negative. All the same. These have names, but basically the same signature. And float into int floats. It seems like a tuple. Because this would be a float by itself, and then this would, well, no, this would be an int actually. Double slash. This would be a float. And it's basically just int a float inside of a tuple. That's what we should say return maybe. Bytes by. Good. Strings optional. I return none. There's our nuns. And on a pinned, that does look like a list. Yeah, initialize there. common for init to be a boolean there, return true, false. Yeah, definitely, I do agree with that. I think the ability to dynamically change the brightness will help us draw a lot of different stuff for sure. Nice. Good luck. Got the fingers crossed over here. Which device are you building for first? You don't have ESP IDF? I feel like I always get a little more tangled up when I do the ESP builds than some of the other ones. But this one, I'm gonna assume all of these are probably Boolean as well. We'll get to them as I think those were further down anyway, so. Right. That looks like a Boolean to me. Here. Looks like it could be done. Right now. Done. If I don't use UART very much. UART in here, and then look at the read function and see if it's bytes, I think. bytes. Read from byte string. In our case, we're going to be writing to. And so write return. Number of bytes written, or none. I've definitely run display IO stuff on 8.0, but I don't know about the shapes specifically. In your testing, have you done, is it only polygon or also rect and circle? I actually don't remember how. I think I did use polygons. I think I think I have vector IO to make a rectangle which serves as kind of like the backdrop of a menu. I think is the only shape I did. Let me take a look though. I'm not always. Yeah, there is one in the issue. Yeah. I do use vector IO to make a rectangle for a backdrop. We do also use progress bar in there. There was a progress bar for the well, there's a new progress bar for the level round that Paul added, and then there is the original progress bar was for health, which I don't know internally if progress bar if that uses shape. May very well though. I wouldn't. Definitely interesting. I've not run across anything that I recall where it was really slow like that, but it does. I do think it implies something probably deeper inside bitmap or somewhere that would have changed to make it different from 7.38. Yeah, I got a link right here. I'll drop it in. Interesting. I'll try to trace it down a bit. If we can isolate kind of where it's at in the core, we could figure out what changed around it. See if we can figure it out. No, let's see. I'm gonna jump back to this. Better than Oh, I put it. Sorry, yeah, I put it in the I put it in the help. I think this is the help desk chat, which is underneath. It's a what do they call these threads? I think underneath CircuitPython dev. Okay. Yeah, I don't see anything. Nothing really jumps out to me from the test code that seems like it would be problematic. And then yeah, based on the print results that you've got there, it's like a bit slower for several of them. I will definitely try it out here in a bit. Um, my guess is yeah. Yeah, I was just gonna say, yep, my guess is that it would, well, either it will behave the same way, or if it doesn't, then that actually helps us narrow it down further, because if it doesn't, then it suggests that it was some change inside probably the atmel port rather than you just like core CircuitPython display IO that's shared. I think it's helpful to test any port at this point, yeah, because it will either be the same, which tells us that it is larger than just a single port, or it will be different, which helps us narrow it down to a single port, or start crossing some off at least, I guess. I'll try it out on a device here in just a couple of moments as well. We have quite a few. What was that highlighted here, and then we'll come back to the review and test out this display IO thing. I'm definitely a sucker for a good display IO history. We're gonna go with displays. Let me on this camera maybe. Really? Yep. Uh, yeah, I'd say go ahead. You can either, if you're comfortable to do it over the voice channel here, you can, or if you have links or anything you want to point to or anything like that, you can drop them in the text chat that's underneath CircuitPython dev. But yeah, ask away. Yeah. It's in a thread underneath that one. So CircuitPython dev is the name of the channel, and then the thing immediately below that is community help desk. Uh, okay. Okay. Yeah, no worries. Alrighty, yep, hope you're feeling better. Um, I mean, it's definitely alright to discuss. I don't think there's any harm in bringing it up. I will say I think a lot of the folks we have gathered are more geared into the CircuitPython world, so we may or may not be able to help as much with stuff outside of there. But definitely no harm in asking, and I'm sure everybody here is happy to help out if they can. I mean, it would be. There's certainly some limitations to the matrices because it's limited in the number of pins, but I don't know that there would be any limitations beyond the number of the pins, but I can't say as though I do too much. Let me pull up the guide that you've got here. You tried running whatever is in this QMK, maybe? Okay, so just to make sure I understand kind of where you're at, Helix, with your keyboard. So you already had successful builds of QMK with the Teensy, and all the hardware and everything was all working out fine with the Teensy in your keyboard, is that right? Okay, and then you're switching over to KB2040, and then are you having trouble building QMK, or you get a build and it's like when you go to flash it that you have trouble? Looks like UF UF2 is one of them. That's certainly what we do use for CircuitPython. It looks like UF2, yeah, based on the guide here, kind of run like, let's see, where's the actual command you run? So well, this is flash, I guess. Make start. Okay, I did it most of the way through this guide. So is the command that you run when it doesn't work essentially, is that the like QMK flash and then a bunch of other arguments after that? Can you, is it in a terminal or somewhere where you can copy paste the errors that it has? That one looks quite a bit faster. Maybe it is Atmel. Yeah. Yeah, I mean the whatever is causing it to be slow. Although it may be worth, if you have a moment, try going to 7.3.3 or whatever the latest release in the 7.3 branch was, and try the same code and see if you get the same numbers. That would be helpful to know as well. No, no, yeah, for this, for the shapes there, yeah, we get those numbers for 7.3.3. I mean, if it's, you don't have it handy anymore, it's no big deal, but. I'll be back in just a minute. I'm gonna run and grab a Pi portal. Pi portal. So it's 7.3.1 right now. Run it on that to start. So Do not find that someday. I'm already. It's gonna be. So it stays on the screen. It probably doesn't matter for the purpose of the test, but. Actually, I can. It's the. Well, it doesn't. It doesn't draw them to the display. It creates triangle objects, but it would still need like. Looks like it would still need to add them to a group and then show the group in order to actually see it on the display. Actually makes our wall tree is not going to do anything since we're not showing it. But that's right. I think we're going to the wrong device, maybe? Yeah, I had another one. It's probably the PyPortal here. Yeah. So, a little bit slower. Yeah. And in that case, it looks like it's sped up, right? These numbers higher is slower. Is that right? Okay. So then it did, in the case of the ESP32S2, it actually went the other way around. It got faster for 8.0. It does look like potentially we have something specific to Atmel. Or at least excluding ESP32S2. Start a response back here, so we'll have the couple extra data points. I'll just put the put in. Yeah, if your yep, it looks like your display is not built in, and then so board.display will not give you, well, it won't give you an object, which means you won't be able to get height and width. Yes, yeah, after you instantiate, yeah, I'm just taking a look at that. Nice. Got the run it once on 7.3.1. I'm gonna try a couple newer ones now. Felix, I see your error output here. I can't say as though I have too much experience building QMK, so I probably can't tell you exactly what these things mean. It does look like the number of keys is coming into it, like the info JSON is not matching what's inside the C file, which I guess the C macro file. I'm assuming that's the one where the layout is declared, but again, I don't know too much about QMK, truthfully. One thing I would try maybe is potentially try building the ones that are in the guide and see if you get a build with those, even though that's obviously not going to work for your keyboard. But it would tell you if like your QMK build environment and everything is working as expected. And then if not, like hopefully that will lead to something that can help you resolve it. Come back and then try your board again. Or the other option is like if you get the ones to build from the guide successfully, then it does look like something specific to the configuration in your keyboard. One thing to do would be to like, I know there's a couple of different places where QMK has configuration stuff. There's H files and C files, a couple JSON files. Some of the errors that it's outputting look like just maybe deprecations or differences between, I would assume differences between whatever the teensy main chip is versus the KB2040. I know in CircuitPython land there are occasionally differences between different main chips. Certainly we try pretty hard to keep it the same everywhere if we can, but they do crop up from time to time. I don't know much about QMK, but it's possible that the different main chips could have different limitations or different capabilities, and maybe some of those functionalities don't work. So I don't know how easy it is to turn on and off stuff, but if that's possible or fairly easy, it might be worth like trying to disable some portions of your configuration and see if you can get it to build sort of partially, and then start figuring out like which ones specifically actually prevent the build, if you can get it to go partially at least. Yeah, okay. It would be worth too trying to build the teensy version again, like maybe with the latest QMK or the latest build environment or however that works. Like try rebuilding your teensy one. It may be the case that you get the same errors there. Um, or if not, then that tells you that it is like definitely specific to the convert to. Whereas if you do try the teensy build again and you get the same error, or you don't get, no, you do get those errors, then it tells you like it's not a difference in the main chip, it's just difference in probably the version of QMK. And then at that point, you can either decide like to backtrack to an earlier version if that's okay for you, or you could keep it the new version but try to figure out what the deprecations are and what the new way to do the stuff that you were trying to do was. Uh, yeah, that's a good. Seven three three. How's it going, Axel? Zapping in the lead. Got the races going again today. connected to probably HCM0. I'll restart it again. Close to the same. Data point. Edge. Change that much. Yesterday about how to develop your code directly on the PyPortal. A folder on your hard drive and then copy paste. Yeah, yeah, I remember that from the stream last night. I don't know, I guess if you're hearing me here, I'm muted in the help desk channel, but yeah, I do recall about that. What are some pros and cons? It seems easy to copy the project bundle to it directly and then commit, push for a new version, function N1 in the same repo. The bundle to it directly, commit, push. I think it'd be probably equally easy either direction, like doing your editing in the repo and then copying it to the device. I think would be pretty much equally easy as doing your development on the device and then copying to the repo. The reason why I try to stick with one or the other is just because when I get in trouble is when I do some of both. When I edit something in the device and then edit something in the repo, they're now on like diverged branches that like Git would be able to merge them back together easily, but when I go to copy paste one, I'm like overwriting the other one. So like I make a fix in the repo, then I make a different fix in the on the board, and now I have like two versions where really I need the fixes from both, but as soon as I copy paste one to the other, I'm gonna lose it unless I am like careful to only copy paste the one part of it or something. Whereas just copy pasting either the whole folder or the whole file or something like that is quicker and easier and requires less thought. But of course, that goes and erases whatever my change on the other side was. I do think either way would be easier though, and I don't necessarily always go from the repo to the device or vice versa. Sometimes I change, but the thing I try to do is just be consistent in any one working session. So like when I sit down for the day, I kind of decide whichever way I feel like that day, but I try to keep it consistent that whole time I'm working. Switching back and forth, I end up losing a bit of code in the middle. Eight 0.0 beta for bootloader. similar on 8.0.0 beta. So is this really just, is it Titano specific? So what forgot about was beta 0 on the Titano? I could think is the version of the library too. Okay, we have the Titano here as well, so we'll give that one a try. It would be odd if it's specific to the Titano. It does have a bigger screen, and it is based on screen size. So it would kind of make a little sense. Ah, this is the portal interface. Honestly, or alpha. Go back to bootloader one more. Connect. Good news is I think we're seeing the same thing here. So it's definitely between 733 and 8, and it seems to be Titano only. Fascinating. So we had the change for the brightness, but I think this was not specific to Titano. Let this finish and we'll post it. I think it'd be interesting. I mean, probably we should try to narrow it even further. So what we can do is go to this. We'll found. It does seem maybe specific to the PyPortal Titano. So I've got it running on the regular PyPortal, and I didn't see much of a speed difference. I got the Titano out, and I am definitely seeing that middle one take a much, much, much longer time. So I'm thinking that I have replicated it, although it's not finished yet. The next thing I'm going to try to do is like essentially bisect between 7.3.3 and 8.0 and see if we can find the commit where it changes, and then that will let's start trying to figure out what it is. No, it uses the same library, and in this case, we're not even really using the helper library. It has its own build a CircuitPython, and it is like a different display and some things. I don't know of any specific changes. Yeah, I don't know of any changes that were specific to the Titano. The only one that comes to mind is we did something like fixing the brightness. I think possibly that was another thing Seagrover found, if I'm recalling right, but I could be misremembering. Um, yeah, I can't imagine that having any effect, and I don't recall anything like anything else that could be specific. But I'll work on narrowing it down. It did just finish, and it was about the same as yours. I think 160 seconds or so on that second triangle. So at least we are seeing the same thing, and we're consistent, which is definitely good. It does not. I ran 7.3.3 and it was fast, so it seems like Titano only and 8.0.0 beta 0 only so far, although I'll go back and try a couple in between. Yeah, once we can get, I mean, hopefully we'll find it down, narrow it down to an exact specific commit somewhere in between 7.3.3 and 8.0, and then we can figure out the exact changes for it. Yeah, for sure. Yeah, for sure. Always happy to help out. I'm also always a sucker for a display-o mystery. I really enjoyed digging into this portion of CircuitPython because I feel like I have the best understanding of it. So it's like to be able to stuff like that. Yeah, it's a good experience. I think it's nice to have folks around and just open the doors to people who want help with projects or want help contributing or even just want like introduction or anything. I think it's great to make some time to be available for folks. Yeah, definitely. Yeah, for sure. What's up? So I know how these lists work. So 0.0 is back here. 2 is here, but quite know where 733 comes into the mix. So if are these down here older than 8.0? If so, all of these are newer than 8.0. 18th. Alpha 0. That makes a difference. Zero. No, Metro, it uses the Arduino Uno form factor, but it's definitely a CircuitPython device. I mean, the shape of it, yes, but the actual device, no. It was originally designed with CircuitPython in mind, I think. The original Metro was like SAMD21, and then they had a SAMD51 as well, and then this one is the ESP32S2. But by the time that came along, I think definitely Plan A with that board for Adafruit at least was CircuitPython. You could. Yeah, no, lots of shields or whatever they call the ones that plug in on top. Those lots of them would work. I mean, there are going to be some that won't if they um, don't have voltage regulators if they need it. Like from 5 to 3 could be a difference. But for the most part, they're like pin compatible in the locations and stuff. And so most shields. Mhm. Yep. Yeah. Some folk. Yeah. Some folks I think learn with it's such a small thing, but it kind of just feels a lot like a bigger deal than it really is sometimes to newer folks. I remember feeling this, just the difference between the male and female headers. Like an Uno feels very easy because you can just plug stuff straight into it, and like you keep the breadboard along the side of it. I remember being a little bit intimidated trying to switch from that to the male pins and having to like plug my thing directly into the breadboard, and it took up space that I wasn't used to giving away. And it's a small thing, but I could see how some folks, if they begin on the uh, Uno, Arduino Uno, definitely the Metro could just be a more familiar thing, stuff up and running on. No, no, no. Yes, Metro M4 definitely can run CircuitPython. Um, the old Arduino Unos, those are typically what is that chip? The 30, yeah, 32U4 I think is one of the newer ones that's used there. But I think that chip cannot run CircuitPython. So if that's what you have, then. But it looks like back to our display I/O thing with the Titano 8.0.0 Alpha 0 does not seem to exhibit it. I get 1.7 seconds only for triangle 2 as opposed to like 160 seconds. So we are a little bit narrower between Alpha 0 and Beta 0, where our issue cropped up somewhere. Yeah, looks like Beta. So Alpha 0 it shows it was May 20th, and Beta 0 it shows was August 18th. So about 3 months between them, but both still pretty hot off the presses as far as software goes. Yep, got about or so in between. So start chopping them in between and see if we can't find the magic one. I do also have a Metro ESP32S2 somewhere, Keith. So I'll try out your example from the. I think you posted an issue just a minute ago, right? Yeah, I'll try that out a little bit later on and put back my results on that issue. Yep. Yep. Nope, both of the PyPortals currently, those are Atmel SAMD51s, so they'll be in the Atmel, or if you mean inside of the core repo. Whatever. I think so. To communicate with the screen, I think it does, although I will say I'm not 100% sure. Oh, it started. I do think we're gonna get the slow one though. We are, so we are still seeing it here. I'm gonna try something about like halfway back or so. Kind of cut it in half until we find the right one. Mm. I Yeah, my guess is there will be a way to replicate it without display shapes too, though. My guess is it's got to be something in the core, either inside a tile grid or inside a bitmap, one of the two. Yeah. Yeah. I think it's got inside the core. Generally, if it's going to change from like 7.3.3 to 8.0 or anything like that, when you change versions of the core, definitely I think implying the library is not necessarily the culprit. Now, there could be something to change in the library that might fix it, but the actual root cause has got to be in the core, I think. For sure. One of the, could be, yep. It would help explain like Titano versus standard one. Yeah, I'll work on trying to make a once we get the build figured out. I'm working on bisecting the builds right now. Once I get that figured out, though, I'll also try to make a more just pared down reproducer. I'll see if I can reproduce it without display shapes. So then we can add that to the core issue as well. Nice. Yeah, it's probably tough because it's differently. Yeah, I would mute. They're 161. Oh, there we go. Another 160. So I mean, GitHub offers the ability to search through some in their front end. And I guess it depends, though, if you mean like search the commit message or search the actual like changed code or how you mean. Yeah, no, for sure. I mean, you can definitely search like you could search pull request text. I'm pretty sure you could search there and it would tell you like if anybody mentioned it. But if it was strictly in the code, I don't know for sure if GitHub search will show it to you. I mean, they certainly could. The technological reason why they couldn't, but do not know if they actually do or not. I don't know if the queue has a name, but it's Q string for QSTR. And yeah, like I said, I don't know if the Q, if it's part of an acronym or what. It's basically a way that CircuitPython stores strings to try to reuse them and make them more efficient and take up less space. So like if two parts of the program use the same string, like let's say an error message or a function name or something like that, um, the sort of lowest hanging fruit way to do that would be to just store that string twice. But what QStrings does, in my understanding, which is somewhat limited, truthfully, and all the way specific to CircuitPython, so I could definitely be wrong, but my understanding is it's packing all those strings together, and if one of them is used multiple times, it's only saving one instance of it, but then it's like saving a pointer or an index or something like that somewhere else that tells it that this other string, when you ask for it, is actually the same as the first one. That way it ends up storing overall less stuff at the cost of a little bit of time to do a lookup and maybe follow some of those pointers to find the actual root string. That's my understanding, at least. Okay. Nice. This one didn't. This one did. They're going between these. Aim for the middle. am I closing this? Clicking over to. I'll be back in a minute as well. I'm gonna go get some ice. Okay, I'll be back in a minute. I'll go feed this cat and get a new coffee, guys. Okay. Sorry. Put on the chat here. Okay, it looks like we got the long one. And then it resetted for some reason on its own, but yeah, it looks like we are on the long one. So this was C2. Now we're basically stepping between here to find one that does not do it. So go this one next. let it finish a second time. Branch for me. Oh yeah, my main kids get out of date. From Adafruit main too much. I just start new branches from there. I think we got the fast one. Yep, so that one's fast, so we're close. We're really close now. So this one was slow, this one was fast. We only got two in between. Here. That's the slow one. (7A5D). Sure, 7A5D. Let it finish, but it's definitely. So A1D48E9. This one is fast, if I recall right, and then 7A5D one is slow. I'll double check those just to make sure I'm right, and then I'll post them up and share them with the help desk channel room here. Get ready for this, I guess. Yeah, for sure. Thanks for joining us and hanging out. All right, so we'll go back one just to verify the A1D. CP-X. Don't know a way to avoid copying them with drag and drop. Okay, I think this was the fast one. We missed the first half of what's his name? Worth making those points. I guess I could point to code. Anyway, we only saw the second half of it, and it reset it again, and then in fact it actually did reset again, so we saw the all of it finally, and we do get this. Have found the exact build where it is appearing. I've found our culprit build. Turns out the Titano build with the commit hash 7A5D2, the one that starts with that, is the first one where it gets slow afterwards. I posted a new comment on that display shapes issue that links to that build and shows the output from each one. Look around and try to make a more general reproducer code and then try to figure out what part of the core it's actually coming from. Got got this technique from Dan. I remember Dan fixing something early on when I was hanging around this community. He wasn't streaming the process or anything, but was describing it in the chat, and I was like, kind of fun. It's definitely a good idea. So let's take a look in the code, what it's actually doing. So the slow one that is most exacerbated is triangle 2. Triangle 2 is yeah, definitely. I'm curious to get into it and figure out what it could be. I guess as it may end up being something that seemed unrelated, but for some strange reason turned out to be. And it's on August the 10th is the date for it. Um, on the it's in the S3. Are you looking at the S3 listing? In the Titano, like on the downloads page, or? Oh, okay, yeah. So it won't be, yeah, it's not like a folder or anything inside of there. It's actually I mean, it's basically a listing of the builds that get made automatically each day. So here, I'll drop a link in this chat that we've got going here, the help desk chat, which this is a link to the Amazon S3 page, which is basically just a big old page of. I did, yeah. Well, I did a binary search though, so I only had to do about 5 or 6 or something like that. Out to be in the end, but I did, yeah. Just put them on there and see what it does. Yep, exactly right. Yep, just cut it in half each time, and each time the sections get smaller and smaller, and by the time you're down to only a couple in there. So, pretty well. Yeah, what I've found is the commit right before that one shows the same day, but about 40-ish minutes prior. So 22:59 is the timestamp on the 7A5D build, which is the first one that does the slow shapes, and then 22:20. So 39 minutes prior is the A1D4, which is the last commit where it's still fast, basically. So maybe a PR that day, or maybe yeah. Well, it may be. That's the thing is sometimes like I mean it does seem to be specific to the Titano, but it might be like as a result of some code that is shared. There is just some other property of the Titano that is making it appear this way. Perhaps the size of the screen, or perhaps something else that's connected to it that's interfering in a unknown or strange way or something. It may not be specifically inside that Titano folder. It may still be back in like shared bindings or shared modules and based on something else on the device. Yeah. No, yeah, it will look for like PRs around that date will be probably the first place to start narrowing it down. At some point, somewhere inside GitHub, you could actually plug in the commit hash, I think, that's here on the list of UF2s and um, find the commit message and start tracing it back to figure out if it came from a PR or which PR or where it came from. But, yeah, nice. Take it easy, Dexter. Hope you have a nice day. Thanks for hanging out for a bit, and good luck if you continue working on the builds or anything else today. Yep. Why triangle 2 though? Do the slowest one. So it's height width, it's 000, and then height. So what does this actually take though, triangle? I'm not familiar with the constructor. It was the first one that is slow is 7A5D2. And then the one before it, which is the last one that's fast, is A1D48E9. Put a link. Well, yeah, yeah. Or, yeah, something that happened between those two. So yeah, if there was a different change in between, maybe it didn't get its own commit, or definitely either that one or one in between those two. Trying to look into the triangle constructor now and see like what it's actually doing. You created. I'm not super familiar with how they generate internally. Triangle extends polygon, so probably this will happen with polygon as well. So first things first, I guess, let's take one step back at a time. Let's reproduce it with polygon and then work up the chain, basically. So we know that we have a triangle that does it. Let's make a polygon that does it also. Triangle extends polygon, takes these as inputs, sort the coordinates, and the largest and smallest x values to figure out the width for the bitmap. I'll supervise it with the points being x0, y0, x1, y1, x, y2, which were basically put in order. By these here. For the polygon, I guess we could probably just aim for a big triangle. I mean, a big triangle, probably, right? Grab the examples as interesting. And like brightness from basically a bunch of these words. Although it's removing it from the initialization, I think only, yeah. And or it's getting rid of auto brightness, I see, and setting brightness to 1.0 instead. Yeah. Oh. I'm thinking it might, especially seeing these ones are all tied to brightness, I'm thinking it may be tied to that somehow. One thing we could maybe try is, I'll pull back up that change from brightness. I think it was just a number somewhere. I think the size of or the speed that it would use for the frequency of a PWM pin. So maybe we can try swapping that back and see if it, yeah. Titano, yeah. Right. referencing that number, not realizing that it would have changed or beyond the order of magnitude. Yeah. Yeah. In the months in my memory, but my timeline is, I don't really necessarily get timelines very right from memory, truthfully. Okay. I'm gonna start peeling back layers of the sample code as well and try to get it to use Polygon, and then once I can get that reproducible, then try to get it to use just TileGrid and bitmap directly so that we can get kind of the most basic case. That was, yeah. Curious to get a look at name error. On the fast one, very fast. Go to the slow one just so it's easy to see when we find accurate. Maybe this will be. No, yeah, it will definitely be much, much deeper than the shapes themselves. The shapes just happen to be the thing where it was noticed. Yeah, and that's once I get peel back the layers of these reproducers, I think I'm almost certain we're going to be able to reproduce it without display shapes in the mix at all, with just a tile grid and a bitmap and a. May not even need the display object. Truthfully, it might just be between those two. I mean, I don't know. I'll have to, once we can get that reproducer, we can start looking into the core code around the bits that we get it narrowed down to within the bitmap and tile grid. Possibly in the display. I mean, I can't fathom any reason why the change we made for brightness would affect it, but I am starting to think that that probably does factor in because it's such a big coincidence that we found kind of the two things, and this commit is dealing with brightness as well. So I'm thinking somehow that value that we changed is interacting with something else, which is causing this. I don't know for certain. Yeah. I'm not sure. I don't really have much insight into like color theory. Truthfully, I couldn't tell you even really what gamma is, other than something to do with colors. So far I have got it paired back to polygon. I have a polygon that is orders of magnitude faster on the newer one than it is the older one. It's not quite the 161 seconds like the big triangle, but it is much faster. I suspect it's probably size. Also try to make just a square. Okay. Basic one here, so we'll do just a square. You have it on the screen as well. Hmm. Like a different problem, but we don't. Where did we? 0, 0, 0, 100 should be. I'm not sure. I mean, so far it seems like the Titano is the only one we've had. I would say there's definitely never going to be any harm in trying one out, because the more things we can either, the more devices we can either rule in or rule out as having that issue, the kind of more fine-grained the area that we're looking for the problem is going to be in. So yeah, yeah. I mean, well, and this you can even get by without initializing the display. In this case, you'll have to basically just hard code the height and width instead of having it come from the display, but I'm pretty sure, I'll test this next actually, I'm pretty sure the display and how it's connected probably doesn't matter, truthfully. I think it's just the size of the shape and then when it initializes the shape, because we're not even, in the original reproducer, it's not even actually putting it on the screen at all. Oh, you have to, okay. So if I did want a square, just to make sure I understand how it works. If I did want a square, I could do 0, 0 here. 5. Yeah. Run? No. Yeah, for sure. Thanks for hanging out. So far, that seems to be the case. Yeah, everyone who's tried it on a different device has not seen it. Um, with the frequency thing for the, yeah, I believe so. Third point, this one here. 0, 0, 0 top left, and then oh, X, not Y. Okay. And then you do have to. Okay, yep, it does. Okay, yeah, X and Y. I totally just mixed up X and Y, and that's why I was confusing myself there. And so this one is 9.3. Let's make it a little bigger. Let's see if we get it, and we'll test it on the other build. See if it slows down. Also curious if outline versus fill makes any difference. I think that will help shed some light on the root issue as well. So right now we have 7. Okay. Right. Yeah, well, I mean, the way, at least what it was back when we made that change, the number did not make it so that you could or couldn't see something. Well, I guess let me backtrack just a little bit. If you set your brightness to full, then everything essentially works the same whether or not you have that change for the PWM value. It only comes into play when you're changing your brightness, and then specifically, it really only comes into play, if I recall right, on like the bottom sort of half to third of the brightness scale. Like, I want to say maybe anything under about 0.4 or something would just like turn the display all the way off, if my memory recalls. And so in that case, you wouldn't see anything, but it's because you had like no backlight essentially. Um, but anything on the upper half of the brightness curve, especially all the way bright, you could still see it either way, um, no matter which number you have. Okay. I guess it looks like. Yeah, that's a good idea. See if just the existence of that pin at that frequency is somehow. Yep, that's a good idea. Right. Angle also. Yeah. 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 And uh, this frequency was not necessarily like the refresh rate, but just the frequency of the PWM signal that's driving the backlight. Refresh rate, I think, is the same across all the different devices as far as I know, and is not something that we did. As far as my understanding is, we didn't. The thing we changed shouldn't affect refresh rate at all. Nice. Sure. Back maybe. Uh, much faster. I So rectangle, 0.2 seconds only. That's our best lead so far. That's the only thing we can think of that changed that is kind of on the periphery of what we're looking at. It doesn't necessarily. Yeah. Okay. You still. Okay. Yeah. Oops. Oh. Well, yeah, I think they got rid of the auto brightness. I don't know that it was tied to the sensor though. It might not have ever been. Yeah. So rectangle of the same size is much faster, even though it does fill. I mean, we're talking like 2 seconds to 0.02 seconds, so 100 times slower almost. So I'm curious about. I believe I was on the slow one, so I'm curious on the fast one. Any difference between shape and rect, or polygon and rect? Does it get slower the larger the polygon being filled, and does it seem like it gets slower linearly to size? Zero point. So this is way. It's still way faster. Makes sense. Access align line segments. Plus calculation. It is way faster with the rect on the fast build than the slow build, then I presume it will be the same thing with the polygon. And still that the rect is faster than the polygon. Most likely true. Yeah. Rect is still way faster than polygon, but each one respectively is faster on the fast build than it is on the slow build. So we'll call them by it. We do have good reproducers. So now let's get, we got out of triangle. Reproduced it with polygon, so next let's try to reproduce it with vanilla disk.io, if you will, just a tile grid. Polygon worse than rect. And tile. Full screen. I think we're off by one here outside, but that's fine. Seven. Funny. Sorry, but I find it amusing. It's neither here nor there. It's Python. Setup. We don't really need the right numbers. What did we have? The TO keeps this. One thing is I don't recall. I think this was our last slow one, 1.7. One more verification here. Brightness code has incidental change from brightness code has an accidental change from height times width. Try in length. Hmm. For sure. Thanks, Tammy. Thanks for being here and hanging out and all the work you did to help coordinate and get everything running. Yep. Yep. You too. Okay. Some guy just came to say that I found Distance of the Game Boy game Game & Watch Gallery. Contains the Octopus game additional version with better graphics. I did see this, the graphics for this one. I did see that one when I was doing a bit of research. I think they re-released it at some point on, yeah, well, yeah, I guess you mentioned Game Boy. Yeah, Game & Watch Gallery. Yeah, largest built-in display of CircuitPython devices, at least. Yeah, I think so. It is, though, it does seem specific somehow to the device still. Even if you draw a shape that doesn't take up the full display, you know, like if you draw a shape that's maybe a 200 by 200 square, which will fit on that display, and you draw the same shape on a standard PyPortal, which is a smaller display but still has room to fit that 200 by 200 square, it will go slower on the Titano, even though like they're both occupying the same amount of pixels. Although it may still have extra work to do, I guess, if it's having to actually do work to turn off or turn black the extra pixels that aren't used, since there are still more of them. I did actually see that version. Okay, we get 3.2 on the slow build, and we got 0.02 on the fast build. And this is with the polygon, which is slower than the rectangle. So let's back it up the next layer and try to make a tile grid by itself that is slow. I tested it on the PyPortal standard, but I'm unsure about the auto brightness, so I don't know if that did or what the state of it was. Okay, I did try it on the PyPortal standard. Yeah, it was removed because I think it never was fully implemented. It was put in as part of the API, but not actually like functional, I don't think. And so those parts of the API got taken out. That way, people wouldn't expect it to do anything. I don't know who it was. If it was, I mean, probably Scott, but yeah. It still has to transmit all the pictures on each raster line involved. I can see that by doing. Oh, that's a good idea. Yeah, Gordy G, that's a good idea. Do as wide but short versus tall and narrow would tell you if it's like scanning to the width. That's a good idea. Yeah, let's do that actually before we do. If we did what I'm gonna do is actually we're gonna make two shapes. I may end up with three actually, but we'll see. 20. We'll go 200. This could fit on both displays. 200. 20. Then down. Over to left. 200. Yeah. That is quite a bit faster than the full one. 3.71. But let's try essentially the same rectangle, but turned 90 degrees. So that would be 100. 100 here, and 20 here. 20. A little bit slower, but not too much. It is interesting to me the difference between 0.71 versus this much closer to 1. It is the same size. I did 20 by 200, right? Yeah. Yeah, Argon Blue. If you're still here, I did the bisection. I'll drop the link. The easiest place to find it is the link to the issue, and I posted both links to both builds basically in the issue. Find that real quick. Okay, actually, I'll go straight to. Some link to or diff. Yeah, for the display, I do think it's connected parable. It might be interesting to release the display and try it, because that's the thing too, is we're seeing the speed decrease even when we don't show it on the screen. So I suspect even if you released the display and just didn't even have it up and running or doing anything with it, my suspicion would be it'd be the same. Yeah, definitely you do. But I mean, it's all, I mean, soldered into the board. Essentially, the circuit is all built on the board itself in this case. Okay. Long and skinny horizontal does make a little bit of difference between tall and skinny, but they are still both slower. In fact, they'd both still be faster on the other build. Oops, sorry, hopefully that wasn't too loud. So I will try to X out polygon, go tile grid only. I did, but it turns out, at least as far as I could tell, polygon doesn't seem to have fill. So I guess I know triangle, I think, did have fill, so it must be doing something above and beyond, but polygon seems to only have outline. I think so. Let me see if we can error code or anything. Because I looked on the constructor for polygon to try to find the argument to tell it what color to fill with, and then came up empty, and then looked in the code and only found an outline argument. Triangle. Interesting. Yeah, the fill inside of triangle, it looks like is actually drawing a polygon and then drawing a series of lines, one line per row of pixels in the display, if I'm understanding right, or maybe per column, I guess. It's basically just like painting stripes of pixels one line at a time to fill in the triangle, which would definitely take more time than, than not doing. I don't see anything about a polygon fill, though. I am curious about where that message. I do think there's definitely something at the root with just tile grid that we'll probably be able to make a reproducer for, so. It's display shapes polygon. Vector IO is a different, it's a similar kind of thing. It's used to draw shapes also, but it's built into the core and not a library. Although it would be worth some experimentation there on the same devices, truthfully, because it may help narrow it down if we were to find out that Vector IO is also slow on these builds. Let's see there. Over on Twitch, hey there, A Studio Roble over on Twitch. Appreciate the follow there, my friend. Thanks for tuning in and watching along. If you have any questions or anything like that, I'm happy to help answer it. Today's a bit of a special stream compared to what we normally do around here. This was the first ever CircuitPython help desk, so a lot of my interaction today is over in the Discord channel, talking to the folks participating in the help desk, but got my stream up here as well so that people can see and that they can follow along. I did X a bunch of tabs. Let's find polygon. I try to make just a tile grid by itself. And so what this tile grid is It's a palette with 3 colors, makes 0. Parent creates a bitmap with height and width, which in our case come from max and min of the points. I guess maybe you could make it fill if you manipulate the palette? Made the bitmap. Looping over points. Creating point A and point B pairs from the points. So each line of the polygon, essentially. And then it's going to draw lines for each of those. The line draw checking some stuff about which is bigger and if they're equal and some things like that, but the actual meat of what it's doing to draw is just a for loop over a range, setting pixels in the bitmap to that color. And then there's a couple of different logics for if these things were equal or not equal or higher or lower or whatever, right? These are all slightly different variations, but in essence, all of them are loop over from 0 to some number, set some pixels inside the bitmap. More stuff here. Basically the same again, you know, looping, editing pixels in the bitmap. This is really all we have. So theoretically, we should be able to just make a bitmap, make a tile grid, edit some pixels inside of it, and that should be slower as well. This example basically is what we want. Although, do we want to create it? I guess we should probably create it here and fill it before we take the time measurement. I'll tell you what though is I'm going to have to step away for just a moment and run to the restroom, so I'll be back in a minute. Okay. Let's go in white and black. I think let's do green and red, green and blue, green and pink. Let's go green and pink. just because black, of course, is the color of the background, so I want to be able to see all of my pixels no matter which color in the palette they are, rather than like some being the same as the background. And we'll do stick to our 200, 200, or we're doing 220 before, but I'll go back to 200, 200. Two colors, there's our palette. So yeah, does this take longer? This will be something, because we haven't painted any pixels yet. We've just created the tile grid, so maybe tile grid constructor also is slower. Name shape is not defined, so yeah, didn't create one anymore. Let's just turn that off for now. So that was very, very fast. 0.000976. I am curious. What I'm going to do is verify this is the slow version. It is. And I'm going to put the fast version and see if the fast version is faster at initializing the tile grid or not. My hypothesis is that it won't be faster, but I'm curious. And it will have run so fast that we won't see it print, so we'll actually started running again. So yeah, 0.0009. So that's pretty much the same. Small variation, 99 instead of 97 or whatever, but basically the same. In order of magnitude, at least. Now we're going to fill in some pixels. I'll just keep it on the fast version for now. So maybe 200. This is a diagonal line, I think. Oh, this is a camera that is live. Blurry camera. A blank screen. Diagonal line. We never showed our tile grid in the group. That is an angled line inside of a box. Does make sense, actually. Yeah. We are all the way up to 0.005 now, so we did jump an entire decimal place, but we are still very, very fast. I'm a little curious. So we print the time before we added it to the screen. So this right now is not factoring in any time it took to actually draw, right? Because it wouldn't have been drawing before this. So we have only time to initialize the tile grid and to set the stuff here. So just to make sure that I understand the universe, we take this out and this shouldn't affect it. We should basically have roughly the same. A 5 instead of a 3. We'll give it a couple more trials. There's a 4. There's a 5. Yeah, I think we're pretty much the same. Which makes total sense since we're not showing it until after. So from 009 to 005, that was because we painted some pixels in like this. So I think we go back to the slow one. We're getting 0.005 here. We're going to go back to the slow one. Uh-oh. Cali girl's here. Outdoor cat wants some food. Want her to sit at the door. If we can successfully hide. Does again. Four, one. So that is 40 times? Is that 40 times slower? No. 8. Okay, well, I thought it was... I was pretty sure I was wrong, and I thought I was wrong the other way. I thought it was going to be less times, but no, it's 82 times slower. Roughly the same we got. We've gotten a few different numbers. There was an 005, there's an 001. So this is without painting any pixels. This is with just initializing the tile grid. 0.0009 is what I recalled from the fast build. And we've jumped around a little bit, but we're pretty much back to that. So 0.009-ish times 0, which is weird. About the 0. 0 feels like a rounding error or something. I don't know what's up with that. But we got pretty close to the same. So it's definitely the changing of pixels inside the bitmap is where the speed is going. More pixels you change, the slower it will be. So it's really hard to see. Huh. Speed is dead again. Could change brightness maybe, but I don't want to mess with brightness if it's potentially even possibly related to what we are. So this is not doing what I think, is it? Thicker line. That's what I was. It's basically the same speed. 0.41. 0.31 was the fastest, 0.41 was the slowest. Got a couple in between. And that's only drawing 1 pixel. Drawing 2 pixels, twice as wide of a line. 0.41. 38. 0.41. Row. This is the same time, right? There's slight variations, but it didn't get twice as slow. Which is actually quite surprising, I think. Why would it not have gotten twice as slow? Sorry. I'm looking in on the live broadcast chat now. Yeah, I've been mostly over in the help desk chat, watching the text chat there, and then on and off in the voice there as well. When you fill a few lines, this is from about 20 minutes ago, and I didn't see it until now though. Sorry. When you fill a few lines of consecutive memory addresses, you could go faster by filling many lines of fewer pixels. If there's mem copy involved, maybe with DMA you can have a big difference. Even drawing vertical or horizontal line can have a difference. Not sure if it applies here, but I've heard that. I do think maybe bitmap bitmap tools. Bitmap tools, generally speaking, has operations that will allow you to basically do this faster, to paint pixels inside a bitmap faster. You can declare regions to draw multiple with one thing, and it does go a lot faster than flipping the bits in the bitmap at the Python layer. So that's one thing that I do definitely think factors in. I don't know how it works under the hood, why it's faster, but I think along the same lines as what you're talking about. Like, it's being able to access and copy regions of memory without doing it individually like the Python layer is. That's my guess or my understanding. Is there a generic fill where you specify a point and it fills up to any color change? If you draw a triangle on a non-black background, does it leave the inside unchanged? I don't know the answer to the second one. If you draw a triangle on a non-black background, does it leave the inside unchanged? I'm not sure. You'd have to try. I think mostly it depends on the make transparency. I think whether it does or it doesn't, by default, make the stuff behind it, inside it, unchanged. Whichever way it works, I think you could change it by doing make transparent on the palette. So if it covers up what's behind it or inside of it by default, you could uncover it or allow it to show through by setting the make transparent of the correct index on your palette. Very confusing because the latency, yeah. The latency with the different chats is true, yeah, sorry. The Feather ESP32v2, I have a SSH11. Do you think the memory of the Feather is enough to run the flip clock? I'm not familiar with ESP32v2 at all, so honestly I couldn't say. I have only used ESP32S2, and that one, the TFT one specifically that Adafruit has, Feather TFT ESP32S2, that one does have enough memory to run the version I posted. So if you check your device, whatever it is, and check the RAM it has versus the ESP32S2, that would be the best way to find out. I'll put this, kind of summarize that in the chat as well. V2 runs only MicroPython. DJ Devin says if that's true, that would also throw a wrench into it a bit. Although I think ESP32, we started recently just getting ESP32 support with CircuitPython using the web workflow. and maybe Bluetooth as well. So it could be a thing where it's like brand new the support for it. But I'm unsure about V2. I don't know if that's like new totally different thing or the same thing, just the modern version. I don't really have any idea. I am fascinated that this is not twice as fast, right? That I did not expect. Um, Now we have 3 pixel line. It's still basically the same, right? 4:1. Yes, I am still here. I will give you here. I'll cut out. I have a bunch of stuff in my sample code, but I'll cut out a direct version of it. I'll give you the version with display shapes, which is where it's kind of easiest to see. But I'm also right now working on doing it with just a tile grid and a bitmap, which I think I've had success with, but I'm also not far enough into it to know for sure what I've seen yet. Be the one I know for sure difference. Okay, I will put it in the text chat here for help desk. Oh, and this is a big one, I guess. If your screen is, I mean, truthfully, the size of your screen doesn't matter too much because I think we're not. This one, I guess, does display it, so I don't know if it may have index out of bounds. Maybe it does matter, but I think the size of the shape matters more than the size of the screen. Okay, perfect. So I was here. I'll run this one on mine. On the Titano where it's having this problem, this took about, let me see here, import. This took 3.40 seconds by the time it printed the timestamp. That's what it printed, was 3.40 seconds. And then on the faster build, it'll be like sub 1 second. Here, switch back real fast. Yeah, on the build before, on the same device, so the build that doesn't exhibit the same problem, it's 0.01 is the speed it prints, so from 0.01 up to 3.4. And there is a little variation from time to time, but that rough pattern kind of emerges. Yeah, 20 pins. I've not had the pleasure to hand wire a parallel display personally. I appreciate the amount of speed that all those wires give it, but it does not look fun nor easy. Just break out of this and go back to CodePy. Or 0.14 here, so this is good also to get a baseline of our fast build is 0.14, and this is back to new example with the tile grid and the diagonal line, so 0.1014 versus we were seeing like 0.47. .3741, that's what it was. So yeah, we are like back here. Not quite this bad. Nice like that. But the multiple pixels, that is very odd to me. I surely would have expected having more of these to make it slower, but that doesn't seem the case. Mini can get slower at some point, right? No? I mean, loop matter? Surely the same as this, right? The fast time was about 0.01. Yeah. It does, let me double check. I believe it does include both though. Double check. So we go up here. Yeah, it includes instantiating both the bitmap and the tile grid and the palette, in fact, actually. As well as changing some of the bits inside the bitmap. All of those are included in the time. That's true, yeah, that could affect it. We could maybe, I can take a second stamp after we initialize it and see which part of it is initialization and which part of it is setting pixels. Okay, so it sounds like, and then remind me what was your main chip? Okay, so it is like that's okay. I added an extra timestamp for after the initialization, and it spins very, very little. Sometimes it even rounds it off to zero, but 0009, my most recent one, and I think I saw one that was like 001 or something like that. Very fast after the initialization, and then so the bulk of the time is in setting the pixels. Strangely, it seems like different ways of setting the pixels sometimes take faster or slower. I'm kind of working through that bit of. We're, we're basically twice as fast, twice as slow. I mean. Yeah, crazy. Will you post a response on that issue and just leave that information there? But yeah, it's super weird because it is, I mean, the same main chip. I know there's like different variations of CMD51. I've never really heard of that making a difference, but that is the only other thing I could think between them would be the difference. Or, okay. standard. One J 19. Oh, oh yeah, you added that back in and now it's slowed down? Ah, yep. Yeah, it's like, cool. This is fascinating. So if you change the exact same pixels inside this loop, so we're only looping through 200 once, which, we are only going through the loop once. It kind of does make sense from that front. But these three exact same changes to these pixels inside this loop is fast, 0.42. In fact, these don't add time, basically. We can seemingly add as many of these as we want inside of here and it never slows down in a meaningful way. Basically the same speed, 4.2. It's almost exactly what we got last time. 4.0, 4.1. We're painting way more pixels. This is frozen again. Oh. Was frozen. Got the focus right. So these don't add any time. Nine additional pixels per iteration. No additional time. But you loop again. We're only putting back 3. In fact, these exact same 3 things just didn't take any additional time. Now that we're looping again, they do. That's weird. Okay, so that PWM is interacting with something somehow to draw slower, but also only after the display, the auto brightness, which seemed unused, moved. Yeah. What? Somewhere in between. Yeah, I have found what seems. Go ahead. Right. Hmm. I have. have found something that feels strange that seems related somehow because it is different on the different builds. But I don't know exactly what it means or how it fits in. So what I have, I'm still working on paring this down to removing display shapes. And so I have a tile grid and a bitmap, and I'm just painting some pixels into it. What I have found is that if you loop once, so I'm like looping from 0 to 200 once, setting some pixels inside that loop. So one thing that's odd is it doesn't matter how many pixels I set in that loop. I started out just setting 1 per iteration, but I went up to setting 4 pixels per iteration, even all the way up to setting a lot more, like 10 pixels per iteration, and it finishes in the same amount of time. So changing more pixels inside that single loop does not add additional time that it takes to print, like by the time it prints out the time. It'll be the same whether I'm setting only 1 pixel or 10 inside the one loop. But if I make a second loop afterwards that loops to 200 again and set some pixels inside there, it takes basically double the time. But the thing is, the way I set it up is, in my second loop, I'm actually changing the exact same, in this case, 3 pixels, but I suspect it doesn't really matter the number. I'm changing the exact same 3 pixels that I had tested in the first loop that didn't take any additional time. But now that they're in the second loop, they take twice as long. So, like, the fact that there's 2 loops makes it take longer, even though it's actually touching and changing the exact same pixels, just inside 2 different loops. And what I have found is that on the old build, the build that doesn't exhibit this problem, that is not, doesn't appear to be true. It takes the same amount of time whether I do it all inside one loop or I do it inside the second loop. But on the newer builds where we do see this issue, then I see the difference between the one loop and the 2 loops, even though they're touching the same number and in this case even the same exact pixels. Super weird that I think looping over it a second time would add more time basically, since it's changing the same thing. So old build seems to behave how I would have guessed. The new build makes it take longer when you loop the second time, but both results are a little surprising to me. The fact that adding more pixels inside the single loop didn't get slower, and that having the second loop does get so much slower on the newer builds. I don't know how that fits into the puzzle. I'm gonna head out for a bit though and get some lunch and work on some other stuff and go out to the world, do some shopping and things. So I'll head out for now. Thanks everyone for participating and helping out, and I definitely had fun. So I look forward to setting up another one of these. Okay, we'll do. Yeah, thanks for trying it out. All right, so yep, as you probably just heard a second ago, I'm gonna head out now and get some food and go take care of some other stuff. Looks like, well, you got this running pretty nice though, at least as far as drawing stuff. Yeah, thanks, Gordy G, for hanging out. Thanks everybody else who has hung out, watched along, participated in the help desk, participated in the chat, all of that stuff, all the followers. Got a couple new followers on Twitch there, so thank you to those folks. Thanks to everyone watching. Hope everybody's got a good day and a good weekend and all that stuff. And yeah, I'll see you next time. Gonna head out for now. Thanks.